So Linus Sebastian and his team made a new screwdriver, and they shared the story of how it went along, and we thought it is an awesome example, and we want to dive into it a little bit more. So first of all, I just want to say thank you to the team at LMG for both sharing this story and all the details of it and actually creating the screwdriver and bringing it to market. Congratulations on that. But this is such a difficult journey to go on that having a lot of transparency about it is a really big deal because it's very unapproachable, especially for new product designers, about how difficult it can be and what a lot of the very specific, but also very common, unfortunately, challenges are when creating a new product. So with that, let's just dive right in and look at the video.
Everything from the convenient bit storage to the perfectly tuned sound and feel of the ratchet mechanism to the fact that it is naturally perfectly balanced, as all things should be.
So screwdrivers should be perfectly balanced. It is something that very few people really care about, but when you're working with them, it's really handy.
Is second to none. And the handle is designed to be super comfortable, whether your hands resemble catcher's mitts or you buy your gloves from the children's section.
So here's the thing, with the universality of parts and that kind of thing, it's difficult to do. We actually haven't been able to get a hold of the LTT screwdriver yet, so I can't actually react to that. Generally, when creating a general mechanism or a general fit for everybody, it ends up being kind of lukewarm for everyone, so I don't really know what the fit is. But from a design standpoint, that's something you don't target very often, and if you do, it's very difficult to hit. I do know they use kind of an original design on this that they go into a little bit later on, but again, design practices, try to be very specific and intentional about what you do and don't always try to create something really generalized.
To this point was an adventure, and even with my experience in product management, a shockingly expensive adventure. I mean, how can it take 3 years and hundreds of thousands of dollars to make something so seemingly basic?
3 years and hundreds of thousands of dollars to make a screwdriver. That is not unreasonable or uncommon at all. Many folks fall into the mistake of thinking that it's going to be quick and that it's going to come out right on the first try, but creating a new product is a journey that is very expensive and very long-term, almost regardless of what type of process that you do. Here at Slant 3D, we've worked to try to reduce that cost, but it can still be very challenging. So when committing to create a new product and being very persnickety about the details of that product, you have to commit to a pretty large undertaking. It is almost the creation of a full company, not just the creation of a product and store a few of them in your garage. It can be tough. Additionally, the screwdriver is seemingly basic, but they have a ratcheting screwdriver, which has all types of different complexity in it that is not that common. This would go into what would be considered a complex product because it has almost more than a dozen pieces in it. And we'll get into that more.
Rather than reinventing the wheel, the smart engineer finds the best existing wheel and then refines it.
So, quick note on there, that is true. Do that. There is no reason to be that creative if there are very solid and proven solutions out there, because creating a whole new thing is a very high risk decision unless that creates such enormous value that it's really worth it.
MegaPro was an obvious partner. First of all, their ratchet mechanism is fantastic and has been proven reliable in the field for over 25 years. Second, they own the patent on what I believe is literally the best bit loader available for a ratcheting screwdriver. Third, and this wasn't a requirement, but it was a huge bonus, their office is a 20-minute drive from ours.
So Linus mentioned the patent. So they licensed the patent for the bit holder from MegaPro, which is pretty nifty. But in licensing, that is always a consideration. So you have to actually do some research before you commit to the really long journey of creating a product to see if it actually exists already. Because, kind of a spoiler alert, most ideas have been done already, and there's very few original ones left out there. Many original problems to be solved, but many product designs and things have been invented already. So very often you are an implementer who either has to license it or really find an original spin. We'll talk about patents at some point in a future video, so folks kind of get a differentiation of it.
Now, the especially smart thing to do, what MegaPro implored us to do, would have been to simply rebrand one of their existing drivers. A little bit of LTT logo there, some LTT color here, maybe some computer-specific bits, and we would have been good to go. Unfortunately, I'm a perfectionist control freak who hates making money.
So that is the smart way to go. If you're creating a piece of custom merchandise, you do not want to create an entirely new product that's inspired by another one. It's easier to stick your logo on something that is legitimately good. And in this case, that is perfectly reasonable to do. But Linus, he says, is very particular about what he likes. So he wanted to create a whole new product so that it can actually differentiate itself from other products on the market, because having a logo on a screwdriver doesn't really necessarily make it a better screwdriver in any sort of way. So why create this whole original product if you're not actually going to add something to it?
So instead, we embarked on our 3-year journey that would have us redesign nearly every single aspect of MegaPro's existing product. Does this look anything alike to you? I mean, they're both screwdrivers. Other than that, the answer is no. For one thing, MegaPro's ratchet works in the opposite direction that you are screwing in. And not being able to alter this would have been a complete showstopper for me. Upon hearing that it should be pretty simple to go ratchet right, screw in right, we greenlit the project. More on that later though.
So this is a really good foreshadowing. Simple changes can have really big impacts because they impact everything down the chain, from the design of the overall item to just being more complex than what you thought it was going to be. Even if the expert designer, MegaPro in this case, actually knows how it works, they can make an assumption about what it could be, but at the same time, you can run into some hairiness, especially if the designers or the product creators in this case aren't super specific about it. There's ambiguity in the creation of a new product. And that's not to diss on Linus at all. It's just that you don't know what you don't know until it comes up. So even someone who is educated and familiar with the product can't always anticipate everything that will come down.
Next, we had to redesign the handle. To be clear, theirs is great for automotive applications where you really want to give her up near the top of the driver, but it didn't provide the finer control that I expect in a more general use driver. Also, it's a little more than I can handle, if you catch my drift.
So that's basically Linus laying out what the problems are with existing drivers. So that, in the context of communicating what your product is, that's a really big point. Be clear about the problems that you're actually solving so that when you show your solution, people understand, oh, that's how you fixed it. Okay, I see the problem, I see the solution, I understand why you're better now. So in the context of marketing your new product, that's a really good thing to take home.
At this point, I was recruited to design a handle that feels both when you have your hand up at the top or when you have it choked up, kind of like this. I settled on a 3-lobe design for the way it just kind of naturally follows the shape of your hand, and from there, I got to do my favorite thing, rapid prototyping. My philosophy is that there's no point in trying to make something perfect the first time because you're just gonna get it wrong anyway.
Perfect point. There is no point in trying to get it right the first time because you're gonna get it wrong. There will be something wrong. So embrace that. Try to go as far as you can on each iteration or something like that, but expect it not to be right. Very often in product development, you're going to get through about 90% of the product. You're going to get it 90% there, and that'll be done in like 20% of the time. And then you spend the rest of the time tweaking stuff, getting it a little bit closer, a little bit better. And since each one of those iterations still takes days or weeks or sometimes even months, it starts to take a really long time because you're just making tiny tweaks, and those tiny tweaks take as much as almost starting from scratch sometimes. So don't be frustrated by that, but embrace the wrongness as you're going through it, because things are going to go wrong.
So for my first attempt, I basically just made up dimensions in SolidWorks and threw it at the printer. This is truly terrible. But that was kind of the point. We already knew at this stage that the final parts were going to be injection molded, basically shooting a bunch of hot plastic into a metal cavity. So there are a couple of important considerations.
So this is important too. During the design process, you have to know where you're going. This is something that we run into with clients all the time. If you when you are designing a part, you have to know how you're going to mass produce it later on. If you're going to mass produce with injection molding, you need to take into consideration the design requirements of injection molding. If you're going to make it for machining, you need to take into account, is it machinable? If you're going to mass produce it with 3D printing, you need to design for 3D printing. These things do not overlap. So you cannot design for injection molding and then decide to 3D print it later on. That's a very bad plan. So it's best early on when you have kind of an iteration that you're happy with, a prototype, a rapid prototype of the product and some designs of it, to reach out to manufacturers right away and start getting quotes. With this, be open and available. Don't get bogged down in this part of the process. Don't try to hold up NDAs and that kind of thing, because if you send them to a different country, they're not really very enforceable. And if you're sending them to local manufacturers, it's sort of insulting that you think they're going to steal your idea, because they're in business making people's ideas. Again, not a lawyer, and do use an NDA when you feel it's appropriate, because it's okay, but don't let that bog you down. Pick a good, honest company that has been around for a while and work with them. They are a collaborator with you, and prepare for that manufacturer down the line, because it is a partnership and it is a back and forth. So you have to be ready for that. But design for the end process in mind, and don't design the product and then figure out how to manufacture it. Those are the same process.
First, no areas can be too thin. At below about 80 thousandths of an inch, our molten plastic won't flow through the mold.
So these are a lot of good details about molds. This is the 3D printing channel. We're not going to look at that very often, but it's a good thing to look at inside of the video, and actually to go into more detail if you're creating a molded product or a 3D printed product. Look at the details and the engineering requirements for creating for that process.
Unfortunately, this was one of our first major roadblocks. Linus said it was too big, and I had already made this handle as small as I possibly could without changing the Mega Pro internals.
So this is one of those issues. The handle is too big, but they can't make it any smaller without changing the actual mechanisms themselves, which was supposed to be the easy pre-made part that they just had to tweak a little bit to change the stiffness of it. This is really common. If you change one thing in the spec of a design, you'll probably have to change other things, because everything on a well-designed product is very interdependent. So again, make sure you have that iteration up front and you know what can be moved, what is absolutely set and cannot be readjusted, so that your engineers and your designers know what can be changed and what can't, and can build specs around that. But this is also the challenge about using other people's stuff. Their stuff can't change. It's how they make it. So yours has to. And this is what starts to cause problems, because now you have this cascading effect of having to modify things to meet that fundamental spec.
To make it smaller, we'd have to get pretty creative and spend a bunch of money. One option was to decrease the length of the zinc housing that connects the shaft to the handle, but we were afraid that would decrease how much torque you can transmit through the handle. Another option was to decrease the number of bits to 6, but we felt 12 was a necessity for tech work. What we were willing to give up though was the length of the bits. By reducing them from 25 millimeters to 20, and making a couple alterations to the zinc housing, we were able to make our handle nearly an inch shorter than Mega Pro's, and create a handle that is awesome to use no matter your hand size.
So this is a very good demonstration of the engineering design process. There are some things that you can trade for, some things you can't. So you go down the list of what can be adjusted, what can't be adjusted, and try to find something that you can move. And shortening the bits is not an obvious answer. It's something that you have to kind of stare at and mess around with until you stumble upon it. Like, oh, well, we can't make that shorter and we can't make this fatter. There's the bits though. We can get bits a little bit shorter, and that's not that big of a deal. So this is, again, part of that process of just messing through each one of the problems until you find the solution. Which again, if you are not the one as the product creator going through that process, it becomes very expensive if you're outsourcing it. If you have an engineer who works for you, they are billing you hourly to come up with those solutions, which can sometimes just be rumination or kind of an eye doctor test. Do you like this? Do you like this? Do you like that better than this? Which is not something you want to do as a new product creator, because it adds a lot of cost. So again, be very clear about what can move and what can't, so that you create these constraints that a consultant or an engineer or someone on your team can move very quickly and focus in on what can be changed that could potentially solve that problem.
2 versions later, we arrived at version 7, which is a handle design you can buy now. I did create versions 8 through 20, but all of them are worse than number 7. So 7 it is.
There was a small problem with our handle design though. how do you access the bit loader? MegaPro has two little indents on the sides of the handle, but with our trilobular design, that looks and feels pretty gross. To make the whole driver feel more cohesive then, we hired Whitebox Designs in Vancouver to help us out.
So Whitebox Designs in this case is probably an industrial design firm. This is again kind of an expensive thing to get because an industrial design studio is someone that you pay to consult and be creative about how to make something appear and how to look. They do very often like packaging design and housing design and that kind of stuff, but they're very good about creating an aesthetic that holds to your brand and creates something that maybe an engineer is not that good or doesn't really have the eye to create. So this is kind of the difference between engineering and design. Linus is engineer. We're able to create the functional design and say the handle is this much, the ratchet works this well, but then they have the industrial design firm come through and do a once over to kind of clean it up, make it look nice, make it feel cohesive and look right for things like indents that aren't really engineering necessities and won't fundamentally change how the part functions, but change how a customer interacts with it. So industrial designers are very good about creating a feeling within a product so that the customers actually enjoy it and it doesn't have a function over form type of style, which can be kind of off-putting because we're human.
Some resembling things like our water bottle and some a bit more abstract. Around this time, it was becoming pretty clear that Alex needed some help since balancing doing an engineer's full-time job with writing an LTT video a week was becoming unsustainable. So we went engineer fishing and hooked ourselves a Kyle.
So this is a big advantage. Yeah, their original engineer, Alex, was too busy because he's actually got to help run the YouTube channel and create new videos. So they brought in a full-time engineer to work on this project. Kyle here. And Kyle has a great background. He has years of experience. He works in mechatronics, which is a little bit weird in that it has a much higher electronics focus, but it's not that weird for LTT because in the context of the rest of their company, they're trying to create a lot of different types of accessories and products that have electrical components to them. And mechatronics is a combination of mechanical and electrical engineering. A lot of mechatronics guys end up working in robotics and that kind of thing, or in this case, building computer type hardware. So it's awesome. It's tough to hire a full-time engineer. They are expensive. So again, you're kind of in the boat of having to do a consultancy. But if you're able to do it yourself, that's better. If you have a friend, that's okay. If you have a co-founder, that's even better. But if you're able to bring on a full-time engineer, mechanical engineers, electrical engineers, make sure that you know what you need to get created and don't just hire an engineer.
His first task was to perfect our end cap. We liked Whitebox's little ribbed ends, but getting it correct was difficult since too large of a rib can make using the screwdriver uncomfortable in your palm, but having them too small makes getting at the bits difficult.
So this is interesting from a manufacturer's perspective, because that is a subtle requirement that many people brush off as like, Linus, it's okay. They're ribs. They're not going to bite into your hand. And if they're too small, well, they're small already. The fingers are going to slip. You're going to be sweaty that day, whatever it happens to be. This is something that you as the product designer, the project lead, in this case, Linus, has to be very clear and very concise and very strong about, because you're going to get pushback on this kind of stuff from people who think this is ridiculous. Who cares about this tiny little detail? It's the rubber ribs on the back of a screwdriver, Linus. Who cares? He cares, and he needs to, in order to make sure that that screwdriver doesn't slip, because those tiny little details start to edge back and back and back, and you start to create an amorphous product that is compromising throughout. So it is necessary for the product lead to be very firm about what can and cannot be done. And this is tough because, again, it requires a fairly strong will, because there will be pushback and there'll be recommendations that are made in an honest and concerned manner of like, this will increase the cost pushing for these ribs. And you'll say like, nope, we've got to have the ribs. So you have to commit to that. It is almost a Jobsian level of commitment to minor details that make sure that the big details are also well taken care of.
After 3D printing a bunch that could be interchanged quickly using magnets, we found that this one was the best. All of this work led to the 3D printed prototype in my hand. looks strikingly similar to the finished product, doesn't it? So given that this was high fives all around done in August of 2020 with the launch scheduled for 5 months later, how on earth did it take another 2 years?
If they had gone right into 3D printing production, they could have done that. The handles of those screwdrivers could be produced with 3D printing, a number of different processes. Again, depending on what the final standards were and that kind of thing. And if they were fine with that and it's darn close to good enough, probably some details that Linus didn't like in the 3D printed prototype. But 3D printing can produce those types of items in that type of scale and do it well. So if they had gone from the 3D printed prototype straight into production, that would have been possible. But since they now had to make this translation over into molds, they start getting into new, fresh hairiness. So they had the prototype. If they were mass production with 3D printing, the prototype would be the production model. But since they now have to go into molds, they're moving into that next phase of having to deal with these next new process issues. Hey guys, so this video was way too long to release all at one go, so we've actually cut it into 2 parts. Please like and subscribe to the channel and comment down below if there's specific areas about the LTT screwdriver that you'd like us to talk about a little bit more, and maybe we can get that added into a video down the line. Have a great day, everybody.